calculate best height. We measure the base of each tree at 1.3 meters above the ground using the diameter plane, and then we record the base for each tree. Then, in terms of spatial distribution, we use the measuring tape to determine the distance between the selected trees, and then we record the values. And then the sampling design, we use quadrant sampling to divide each array into quadrants, and then we use systematic sampling technique to collect the data. In terms of data collection, we collected deviation and distance to neighbor of 10 eucalyptus trees, and also deviation of 25 and cedar trees. And then we calculated the mean, median, mode, and range for these values. And then we used Microsoft Excel to determine the t-test to conduct the t-test and correlation between the tree diameter and spatial distribution, and also the tree diameter of two different plant species. There are some of the descriptive statistics of some values like the deviation of eucalyptus trees, pine trees, cedar trees, both the deviation of both the pine and cedar trees, and then the distance to neighbor of eucalyptus trees. Let's analyze each of the data. In terms of eucalyptus trees, average deviation of eucalyptus trees is 15.4 cm, very close to the median, and the range is very small, 2.2. In terms of pine trees, the average is 21.91, very close to 22, and the median is also very close, and the range is bigger than the eucalyptus, near to 6. Then in terms of cedar trees, the average value is 7.65 cm, the median is very close, and the range is almost same, 5.55 cm. And then in terms of the deviation of both pine and cedar trees, the average value is 19.78 cm. The median is very close, but the range is huge, almost near to 10 cm. Because both the pine and cedar trees have distinct characteristics, distinct sizes, so that's why the range is very close. And then the distance to neighbor of eucalyptus trees, the mean and median is all absolutely same, 2.15 meter, and the range is very small, 3.5 meter. Then we conducted t-test and correlation of two cases. In terms of t-test, we performed t-test of DBH and distance to neighbor of eucalyptus trees, and then the DBH of both pine and cedar trees. So, in terms of t-test of DBH and distance to neighbor of eucalyptus trees, the one-tailed p-value and the two-tailed p-value both are below the significance level of 0.05, which indicates a very significant difference between the DBH and distance levels. And in terms of t-test of the DBH of both pine and cedar trees, the same almost. The one-tailed p-value and the two-tailed p-value both are below the significance level of 0.05, which indicates a very significant difference between the DBH of pine and cedar both trees. And in terms of correlation, there are two cases. One is between the DBH and distance to neighbor of eucalyptus trees, and another is between the DBH of pine and cedar. So, in terms of correlation between DBH and distance to neighbor of eucalyptus trees, we find a very weak negative linear relationship as the correlation coefficient which is -0.132. The amount of tree diameter cannot significantly influence the spacing around them because of various other factors like physics, personal mechanisms, soil conditions, climate variability, etc. And in terms of correlation between DBH of pine and cedar trees, we also find a very weak negative linear relationship as the coefficient reaches -0.005. Here also the amount of tree diameter of pine and cedar trees cannot significantly influence each other because of various other factors like nutrient uptake, light requirements, and wood competition. So now let's discuss the whole study. Our study focused on the relationship between the DBH and spatial distribution within same species and between different species. And in both of the cases, we found a very weak negative correlation. Some studies like Pond 2006 suggest that the tree size and spacing is shaped by competition for light, water, nutrients, etc. And large trees need wider spacing due to the resource needs. Because competition exists between the between the species in a forest, in a ecosystem. So obviously the attributes of trees like their diameter, height, or spacing get influenced by the interspecific or the interspecific competition of the neighboring trees, like competition for resources like light, nutrients, and minerals. And as large nearest tree, the spacing around them gets wider. And so these studies suggest that spatial distribution and DPH are usually linked, not independent. But there are some other studies like this wide 2021 guide and these studies suggest weak or negative DPH influence across species because there are many other factors beyond DPH like heterogeneity, dispersal mechanisms, management practices. These factors play stronger roles than the lineage of the attributes of the tree itself. There are some case examples like Stoll and White 2005, which conducted a study on European beech forests, and they found that species factors like species traits, means species specific attributes, and the management practices, how these forests are managed. These factors matter more than the tree size, the attributes of the tree itself. And according to William 2007, in terms of natural forests, there are irregular species found into various stochastic processes like dispersal mechanisms, animal movement, repetitive relationship. These processes affect the spacing of the forest, natural forest, and then going from irregular spacing. So ultimately we can say that yes, there debates according to various studies, there are mixed evidences. So yes, debates or spacing relations, these influence each other. These sometimes matter, okay. But our studies suggest that it doesn't matter because there are also some other studies that say that there are many other factors like the competition, level density, like the stochastic processes. These factors influence the spacing or the size of the attributes of the tree. So long term, our sample size is small and it was a short term test. So long term